In this video I'll be showing you how to make an alarm clock that makes you get out of bed. Okay, so how are we actually going to go about doing this? How are we going to build an alarm clock that pretty much makes you get out of bed? Well, the answer is this. Some of you might recognise this from my previous video, and it is a capacitive sensor. If you can't be bothered to go back and watch that video, fair enough. It's pretty much a piece of tin foil with a wire going through. Now we can use this as a sensor which is able to detect whether or not you're touching it. So for this alarm clock, we'll be placing it on the floor, so when the alarm goes on, you have to get out of bed and stand on it in order for the alarm to turn off. That's pretty much the idea behind this project, so let's get into it. So we'll come back to the sensor a bit later, but in the meantime let's see what else we'll need for this project. To start off with, we will of course need an Arduino, then an LCD screen, a breadboard, a piezo buzzer, a 1 to 10 mega ohm resistor, a 220 ohm resistor, although I'm just using two 110 ohm resistors, and one long wire that will be able to go between the sensor and the alarm clock. And of course, a load of connector wires. Okay, now I'll admit that the screen I'm using for this project isn't exactly the most aesthetically pleasing, which is why if you want to turn this into a bit more of a serious project, you might want to go for something a little nicer, which is fine. If you do, stay tuned to part 2 and I'll show you what needs to be changed within the code to accommodate for that. So now it is finally time to build this thing. We're going to start off with the LCD screen, and remember it is really important that we get all the pin allocations right, otherwise obviously it won't work. Or if you really manage to mess up, you could even end up breaking it, which nobody wants. But anyway, now we've got all that sorted, all we've got to do is stick in the wires and the resistors, and the screen is good to go. So next up we have the buzzer. Now this is really simple. Ground pin to ground terminal, and positive pin to pin number 9. Done. We now of course are only left with one thing, the sensor. For this, grab a sheet of tin foil, a long wire, some gaffer tape, and boom. So now we just have to put it in the circuit, which is again really easy. Between pins 6 and 7, put your resistor. For me I'm using 3 mega ohms, but you can use anywhere between 1 and 10. All it does really is change the value of the reading in the software. And then next to pin 7 you want to put in the wire connecting the capacitor. But with all that done, oh no, it's not working. Well no, because we haven't yet done step 2. Okay, so it's software time. Before those of you that have no interest in software shoot off, there is one thing I need to go over, as this will be different for everybody, and that is this little number here. See, this bit of code, it dictates whether or not you're touching the sensor, and it's what tells the Arduino if you are. As such, this needs to be exactly right so that you avoid any anomalous results. But how do I know what I need to do for my specific sensor? Well, that is why I've included this sketch here, and what it does is it prints the value of the sensor onto the serial monitor so that we can see how it differs. If we go to Tools, Serial Monitor, you can see now that the values are quite low. You know, in the 20s, 30s, basically below 100. But if I'm to touch the sensor, they shoot up to the thousands. So now if we go over to the original sketch, I've chosen 800, so that if I'm not touching it, the value of the sensor will never go above 800. But if I am touching it, it will never go below. And this basically ensures that you miss out on any anomalous results. So if for some reason there's a jolt or whatever, then it shouldn't affect the working of the buzzer and the alert system, basically. That's pretty much all there is to it, to the sensor. If you want to learn a little bit more, like I said earlier, there is a separate video on the sensor specifically, so you can go check that out. But in the meantime, let's quickly cover how to set the time and the alarm time. So here are the time values. H equals hours, M is minutes, S is seconds. So the time at the moment is set to 10, 23, and 49 seconds. Pretty self-explanatory. Then down here, pretty much the same for the alarm. So the current alarm is 11:22 and 33 seconds. And the code works so the moment the time reaches the alarm time, the buzzer goes off, and then the moment you step on the sensor, the alarm goes off. Simple. And that's pretty much all there is to it, to this code. If you want to learn any more, then you can obviously download it, and I've commented it up, I believe, as good as it can be, but if there are any other questions, then of course you can ask me. Now, earlier I did mention that if you wanted to use anything but the basic LCD screen, I'll let you know what you need to do. And so this section here is how the LCD works, and is what writes the values to the screen. So if you go for another screen, or if you decide to go down a more classy digital number approach like you get in most digital alarm clocks, then this is what you need to change. And this will be different for every screen that you use, so you will need to bear that in mind, and you'll need to look into it and research it for the individual screens. But basically this is the bit of code that you need to get rid of and change to meet whatever your user interface is. And in regards to the software, that's pretty much it. All we have to do now is upload it, and we'll be good to go. And so with that, we are done. I hope you guys enjoyed this video. If you did, then please don't forget to leave a like and subscribe if you'd like to see more. I have made a pact with myself to play less FIFA this semester and make more videos, so I'm hoping to start on proper regular uploads now, as opposed to the once every couple of months that's been since the formation of this channel. So if you want to stick around for that, then I hope to see you next time.